Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 92 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to teach you how to get readings off of all 9 of the inertial measurement sensors on the GY-87 IMU module. Now, we've spent some 6 or 7 lessons on this already, but earlier what we would do is I showed you how to read the accelerometers. I showed you how to calibrate the accelerometers. Then we wrote a separate program to read the gyros and then reduce the drift in the gyros. Then we did some sensor fusion where you could get better results using a complementary filter by combining accelerometer and gyro data. Then we turned on the magnetometers. To calibrate the magnetometers is a little bit trickier, so I showed you on the Python, on the desktop PC side, you could write a program using Python and PyQt to pull the data from the Arduino and then do the calibration on the Python side, on the PC side, because we could create visuals that would help us very precisely calibrate the magnetometers. Now, we learned the magnetometers are a little bit trickier to use, and so you really got to be very deliberate in the way that you calibrate them. So what do we have? We've got kind of a hodgepodge, and part of it we were calibrating on the Arduino side, part of it we were calibrating on the PC side in Python. And so what we're going to do is we're going to just stop and do it methodically. For those of you guys that have taken the class, this is going to be kind of a straightforward review. But what we're going to do today is I'm going to show you how you can measure all 9 sensors at once on the Arduino side. What your homework assignment for next week will be to then over on the Python side on the PC to go in and write a program in Python that will calibrate the accelerometers, will remove the drift or reduce the drift from the gyros, and calibrate the magnetometers, okay? And so we'll be doing all the calibration on the Python side. That Python program should generate a set of calibration parameters for your sensor, and then the week after that, we will put those calibration parameters back over into our Arduino program. So then when we make measurements in Arduino, we're doing it based on calibrated sensors. Okay. Then at that point, we're getting very good calibrated data for all 9 of the sensors. And then we can start working on our project. You know, you can imagine we're going to add a little screen. We're going to add a little screen to the Arduino project, and then we can create things like a digital level, an inclinometer, you know, a magnetic compass. There's all types of things we can do when we get good calibrated data on the Arduino side. Does that sound good? I hope it does. I am doing way too much talking. And so what I'm going to do is we're going to jump in now and we're going to start working on our code. And so what I'll need you to do is fire up a fresh new Arduino IDE. And then you guys that have been taking the class, you should already have these libraries. But if you're just a drive-by shooter that is dropping into this class, you need to come over here, open up your little library icon, and you need to search on Adafruit Unified. And then for some reason, it gives me a lot of things that I don't want here. I think it saw Adafruit and then it's just going in alphabetical order. But you scroll down and you find hopefully eventually, the Adafruit Unified Sensor Library. You can see I'm on version 1.1.15. As of making this video, that's the latest version. And then you can see it's offering me remove. It's already installed on my system. Now, the other thing that we're going to need to do is we're going to install the Adafruit MPU 6050, because even though we're using the GY-87 module, on the GY-87 module is the MPU 6050. So we're going to need to install that. I'm on version 2.2.6. That's the latest one here. You can see I already have that installed. And then you are also going to need to install the library for the magnetometers, okay, because there is that QMC 5883L 3-axis magnetometer on the GY-87 module. So we will need to look for QMC 5883L, and let's just see what comes up there if we do that. Okay, here it is, QMC 5883L compass. You'll need to put that in. I'm on version 1.2.3, latest one as of the time that I've made the video. So we have our libraries installed. Now let's go in and, it's one thing to get all these things working together, working individually, but we've got to make sure that we can make them all work together. And so I'm going to come up here and we're going to load our library. So we're going to need to include and then open bracket Adafruit underscore MPU 6050.h, like that. And now we are going to also need to include, we're going to get the Adafruit underscore sensor.h, okay, and we just fixed those things. We just we just installed those on the Arduino IDE. We're going to need to include the wire library.h, and then we are going to need to include what pound. Okay, we're going to need to include one more library, and that is the QMC 5883L, be careful of case, compass.h, like that. Okay, so those are our libraries. Let's just run it and make sure that it recognizes the libraries and that everything is working as expected. Looking good so far. It's just if you've got a problem importing the libraries, you want to really find out before you go on. And we like to take the small victories in life as we can. So we're going to do that. It looks like that's going to be good. So we're going to go on and code some more. Let's create our variables for those 9 sensor readings that we are going to be taking. So this is I'm going to go ahead and make them float. And we're going to get AX, AY, AZ for the accelerometer. In the x-axis, y-axis, z-axis, the 3-axis of acceleration we've got. Then we're going to call it GX, GY, GZ for the gyro data, and then MX, MY, and MY, and MZ for the magnetometer readings. Okay, now we're going to create our MPU objects. So I'm going to do the Adafruit underscore MPU 6050. That's the library, and it's going to create an object called MPU. Then we are going to need to also create the magnetometer object, which is separate from the MPU. It's the 3-axis magnetometer, and we will do that with the library QMC 5883L compass, and then that object we're going to call compass. Okay, so now we have an MPU object and we have a compass object. Okay, so that should be good. Now let's see if we can turn those things on. Let's set by doing a serial.begin, and I'm going to do 115,200. Now, why am I doing that? Because before this thing is over, you know, in next week's lesson, we're going to be sending the data over to the Python program on the PC, and there's a lot of data that we're sending kind of quick, so I like running the serial monitor a little bit faster. We're going to see if we can start the MPU 6050. So MPU is our object, and then we will do a .begin, open close parentheses, and our semicolon. Now, so that is going to be talking to the MPU, but the magnetometer, the QMC 5883L magnetometer, it sort of works to the side or kind of underneath the MPU. It's almost like you got to go past the MPU 6050 to get to the magnetometer. So we've got to do a MPU.set I to C bypass to true. Now, bypassing it just means we have the ability to go to the magnetometer, but we're not interfering with the MPU 6050. Okay, so we're going to now, by using this command, we'll be able to access them both. Now, we're going to need to also do a compass.init to get the compass started. And then if you remember in the gyro lesson, we wanted to run that gyro a little bit faster, be able to take measurements at a faster rate. So I'm going to do an MPU.set gyro range, and then that's going to be the MPU 6050 underscore range, and then underscore 1000 and underscore degrees. So we set it in degrees. Okay, we set it by sending degrees, but we got to remember when it sends us data, it's sending us data in radians. How many of you guys have gotten goofed up in a program because of the computer seems to operate in degrees, right? When we do the arctangent or the tangent functions, it's wanting to use degrees, and when these sensors report something like an angular rate, it's in radians. Okay, so the computer works in radians, and we've got to always remember, be mindful to convert our readings to degrees. Okay, let's give it a little bit of time to settle out. So probably 100 milliseconds would be good. And now let's go ahead and run this again just to make sure. It's just so much easier for me to kind of debug as I go than get really into it with a lot of code and then see that I've got a problem. So that's going to be good. That all worked. Okay, what's the first thing that we're going to do? Let's go ahead and read the compass, because that's easy. We just say compass.read. Okay, and that's all you got to do on the compass. Once you do that, then you can go out, and once you do the read, you can go out and get those magnetometer values. But let's do the read there. Now let's do the read from the let's do a read from the MPU 6050. Okay, so that we do with a sensors.event underscore t. Right now, I'm going to say I want the A for acceleration, I want the G for the gyros, and then I want temp. Now, I'm not using temp, but you've got to do the read this way. It's got the data there. You've got to give it a variable to put it in. And so that is how we need to do it. So now that makes a reading, but now what we've got to do is we've got to get that reading. So we do that with an MPU.get event. What event? That event that we just did. And then we've got to do an AND A, we have to do an AND G, and we have to do an AND temp. Okay, and so that is going to put that's going to actually put the data in the A variable, the G variable, and the temp variable. Okay, so now we've read the compass, we've created the event to read, and then we go and we get the data. Now, you have to do this, and you have to do this every time through the loop, because you could go in and say, well, give me a dot acceleration x, but if you haven't done a new reading, you're not going to get a new value. So in our liking to run things every little bit, let's go ahead and do this. I think it's all going to be okay. Yep, it's going to be okay. Now let's actually go in and get the values. So here I'm going to say AX because that's what we set it up for, A dot acceleration dot X. So the measurement's already been made. We're just getting the value and we're putting it in the variable AX. And then I think I'm going to copy this. I'm going to paste. I'm going to paste. And then we're going to have Y, and we're going to have Z, and then we're going to have Y, and we're going to have Z. Okay, so we've got our acceleration data. Now let's come in and let's get the gyro. So I'm going to say GX is equal to, and you could probably guess it, G.gyro.x. And then let's do a little copy and paste here. And then similarly, we're going to get the rotational velocity in degrees per second around the y-axis, y, and z, and z. So we have 6 of our 9 sensors read now. Now we need to get the magnetometer. And so the magnetometer is going to be M in the x-axis, and that's going to be compass.get x, like that. Okay, and then we'll do the other 2. All right, like that. That looks good. Now we need to print all of this stuff out. And we're not printing it to make it easy for us to look at. We're just printing it so that we can send it over to the Python program, which then next week, your homework for next week will be to write that program. Okay, so I'm going to do a serial.print. And what am I going to print? AX. And then I need a comma, serial.print. And then I'm going to do the comma. Okay, and I'm going to take both lines of code, and then I'm going to do, this will be the Y, and this will be the Z. So I will print Y, and I will print Z. So I got AX, AY, AZ. Now we're going to do a serial.print, and we're going to print the G around the x-axis. We're going to do a serial.print, and we'll put the comma again, like that. Okay, let's copy those 2 lines of code, and then it will be paste and paste. So we've got GX. We're going to do the rotational velocity around the y-axis and the rotational velocity around the z-axis. Okay, now the last thing is the magnetometer. So I think I'll just paste, paste, and paste, and then this will be magnetometer in the X, magnetometer in the Y, and magnetometer in the Y, and magnetometer in the Z. So let's just check it here. So we've got AX, AY, AZ, GX, GY, GZ, and we didn't put a semicolon there. If you live by copy and paste, you die by copy and paste. Okay. All right, so AX, AY, AZ, GX, GY, GZ, MX, MY, and MZ. Okay, now MZ. Now on the last one, we don't need a trailing comma, so we'll take that out. And then we want to go to the next line after we print all these across. Now we will go to a new line like that. Okay, does that look good? I think that looks good. Let's get this out of the way. And if we've done this right, this should give us all 9 measurements. So we will run this thing now. Oh, Z. You guys probably saw that. So XYZ, XYZ, get X, and man. Sometimes, I know you guys don't like these lessons long, so sometimes I get in a little bit of a hurry. Okay, so MX, MY, MZ, get X, get Y, get Z. That looks good. I'm going to slow up a little bit and be a little bit more careful, because you would hate to start with a program that isn't getting the things that you wanted. AX, AY, Z, GX, GY, GZ, MX, MY, MZ. Okay, now let's run this thing. Looking good, looking good. Okay, now let's turn on our serial monitor and look at that. I am not getting an acceleration reading. Let me see if I... Okay, what did I do wrong there? So it looks like the MPU 6050 is not operating. So what did I do wrong? Okay, I did the MPU.begin. I did the MPU bypass. I did the compass init, MPU 6050 range, 1000 degrees, 100. That really looks good. You know what I'm going to do is I am going to come over here and I'm going to unplug this. And then I'm going to make sure all my wires are in good. Okay. I'll plug it back in. All right, and now I will turn the serial monitor back on. Okay, there it is. Sometimes if your bus gets locked up, you just got to unplug it and plug it back in. Okay, so you know, probably, did I put a delay in here? No, I didn't. You see, I think I'm going too fast might be the problem. So let's do a delay of 100 milliseconds. And I think maybe the reason that wasn't working is I'm kind of hitting it too hard without a delay in there. Okay, so that looks good. After the delay, I needed to unplug it and plug it back in, and now, yeah, it seems to be working. So what I'm going to do is let's look at this value, and what I'm going to do is I'm going to be tilting the accelerometer about the x-axis. I'm going to be tilting the accelerometer about the x-axis, and if I do, this first number should change. Okay, yeah, you see it is changing. It's responding to tilting along the x-axis. Now I'm going to tilt along the y-axis, which is the second number, and that is working very nicely. Okay, yeah, that is looking good. I'm just trying to see if I can get, yeah, you see, so I'm getting nice big changes if I rotate around the y-axis. Okay, and now this is the z, the third one is the z, and I'm getting nice changes in Z. Now this would be the X gyro, so I'm just going to kind of twist it like this, and I should see that. I'm going to twist it like this. Okay, I'm going to twist it like that because I want to. I'm going to twist it. Sorry, like this. Let me just show you what I'm doing here. Okay, so I'm going to go like this, and you can see that that one is changing. Okay, now I'm going to be looking at this one, and it's very close to 0, and I'm seeing changes there. And then this one, I'm going to change like this, and yeah, that's working. Now let's look at the magnetometer. That would be the 7th one over, and I'm seeing nice changes there. I'm seeing nice changes there. And then about Z, okay, yeah, the Z is changing. So that looks good. Okay, that looks good. And so let me kind of show you what I'm doing for next week, and maybe it'll give you ideas of how you would like to do the calibration. But what I want now is I'm going to stop this, and now I'm not going to show you my program. I'm just going to show you what I ended up with. Now you might do things differently, but what I want is I want help over here with the calibration. So I've created a graphic on the Python side. I've created a graphic on the Python side that will help me do the calibration. So if you look here, I've got the acceleration plotting X against Y, acceleration plotting Y against Z, and acceleration plotting X against Z. And by looking at these, I can spin this thing carefully in order to find those maximum and minimum values. And it's hard to do if you're just looking at the numbers running by. But if I pick this thing up, what you want to do is you want to look at the acceleration data, okay? And you want to look at the blue curve. And you see I can come in and right there at the left corner of the circle, I can play around there making sure that I really hit that minimum. Then I come over here and same thing here, the bottom corner of the circle. Yeah, circle doesn't have corners, but if you think of sort of north, east, south, and west, right there at those extreme points, you can make sure that you're getting something. So you see now, if I'm recording maximum and minimum values, I now have that about the y-axis, okay? Now similarly, what I can do is I can turn it this way, and now you're looking at the green. Okay, you're looking at the green curve. And you see I'm trying to create that circle on the green, and right there making sure that I am getting the absolute extremes, okay? And so then what is the one that I haven't done? Oh, I haven't done driving the truck, okay? So you kind of go this way, you're looking at red. So you see this is going to give me the maximum. This is going to give me the, whoa. And it was off to the races there. Let me see if I can set that again. Okay. Yeah, I kind of bumped the wire and lost the data. And so it messed my scales up. But you see I've got that. Similarly, like for the gyros, like I can try to create in that light blue a circle for the gyro. Okay. So you see, by looking at the graphs, it's much easier to get the maximum and minimum values, and you can tweak it at those critical points to make sure that you're really finding the maximum and really finding the minimum values. And so also then the bottom down here, I just have the gyros, and you can then look, you don't really have to look at these, but you can see that I've got a button for calibrating the gyro, calibrating the accelerometer, calibrating the magnetometer. And then in the end, what I want is I want those, what would it be? It would be 12 parameters for the MPU 6050, because each one of these has a maximum and a minimum. That's 12. And then for the gyro, it's just the offset. So it would be like 15 parameters that you want, and you want it to generate those 15 parameters. Then in the following week, we will come over to the Arduino side, and we will put those calibration parameters in. And then from that point forward, we are going to be just operating on the Arduino side. Does that make sense? I hope it does. And this little thing here, really, if you're going to be serious about IMU data, you really have to have carefully calibrated sensors, and particularly those magnetometers. So I think that a program like this will really help you. And do you see what I'm doing? I'm plotting the x-axis and the y-axis. That would make a circle. And we talked about that in last week's lesson as we were working on the magnetometer. So hopefully this makes sense. Okay, guys, I hope you're having fun with this. Do your homework and post your homework to YouTube. I want to see you guys are really doing this PyQt work, and that you're really doing the parts of the work on the Python side, because really in just about any Arduino project that you're doing, you're always going to be wanting to have the ability of getting the data over to Python. And so I hope you guys are really keeping up with that part of the project. Okay, guys, I hope you're enjoying taking this class as much as I am. Really having fun with the IMU project. It's also at this point that I always like to give a shout out to you guys who are supporting me on Patreon. Great big thank you to you guys. You can help this video by leaving a comment down below and give me a thumbs up. If you haven't already subscribed to the channel, and when you do, make sure you ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.